Okay, so in this graph, it's still those same steps. It's just that we ought to add a line in there that says, in the case where the numerator is one higher power than the denominator, you might have a slant asymptote. Okay, so we'll do everything else, and then we'll go ahead and find the slant asymptote and add that to the graph. So first, let's find the y-intercept. Right? F of 0 is, in this case, -2 over -1, so we have a y-intercept here. Okay, the zeros of the function are the zeros of the numerator. And in this case, the numerator could be factored, x minus 2 times x plus 1. That looks familiar. So the zeros are 2 and -1. Okay, the vertical asymptotes would be the zeros of the denominator. What would you say? In this case, if you set that equal to 0, solve x equals 1 is a vertical asymptote. So let's add that to our graph. There we go. And then when we got to that step that said find the horizontal asymptote, we would have said, well, there's a higher power in the numerator, there is none. Okay, but now we say, but there might be a slant asymptote. So I'm going to go onto a new slide and show you. This is how you find the slant asymptote. Insert page. You divide the numerator by the denominator. Okay? So what do I multiply times x to get x squared? X. X times x is x squared. X times -1 is minus x. Subtract. You get 0. Both terms canceled. Okay, bring down the -2. And, since it's a lower power than what we're dividing by, you stop. So what does this -2 represent? It's the remainder, right? So you could either say remainder -2, or you could say plus -2 over x minus 1. Okay. The slant asymptote does not include the remainder. Right? We're not interested in remainder. We're only interested in this part, the part that comes before the remainder. The slant asymptote in this case is slant asymptote y equals x. Right? So don't worry about this. The remainder is not part of that. Because remember, when you're finding the horizontal asymptote and the slant asymptote is the same thing. That's the value the function will approach when x becomes really large. But in this second term, the remainder, since the x is in the denominator and there's a constant in the numerator, if x becomes really large, it really goes to 0 anyways. Right? When x is large, this term goes away. It's only that. So let's go back to our graph. Now we can add the line y equals x, which means, how about like, that's bad. Edit, undo. How about here? There we go. Something like that. Okay, now we need to do our table of values. You tell me. Could there be a horizontal and a slant asymptote? Because we would say, since the numerator is a higher degree than the denominator, there could be no horizontal asymptote. Right? And so no, those are mutually exclusive cases. Can't be. Okay, now we need to plot some points. We know that there should be some piece of this graph which is to the left of the vertical asymptote and some piece which is to the right. We've already got a pretty good start. I mean, you could almost say right here that these two are pretty good. I mean, if we were going to follow their guidance, it would be, we should plot a point in between the zeros and the vertical asymptotes. We've already got that one. And then one point beyond, let's say -3. That would work. So let me go over here. I think that's going to go there. X, Y. How about, I'll do -3. And then on this side, I only got the 1 point. Pretty sure it's going to go something like that. How about if we do 1.5? We've already got the 0. And then we can do another point, maybe 4. -3, 1.5, and 4. So second graph. Okay, -3, 1.5, 4. So -2.5 twice. Well, that's good. And the other one was 3.3. So we can graph those points. -3, -2.5, about right there. And we could definitely see what's going on. Something like that. Okay, I do the other 2 points. 1.5, -2.5, and 4, 3.3. I think we can see that piece now too. Now, missed it by that much. So now if I look in the calculator, graph, and that's the wrong graph. Let's try zoom 6. You know, like I said, if you didn't put in the slant asymptote, you might kind of in your mind looking at this say, it looks like something's going on there. You know, to look at the way that it's going on at that exact angle and then doing exactly the opposite up there. So that's because there's a slant asymptote. You would have come to the conclusion there's something going on, and that's what's going on.